going to look at concavity. So again, this is just going to be a few definitions here real quick, and then we're going to be using this shortly with what we call our second derivative test. So we just want to understand what concavity is and how it relates to the first and second derivative. All right, so what's our definition of concavity? So if we have some function f, and we're going to say that it's differentiable on an open interval I, so that's just some interval, and then the graph of f is concave up on the interval I if the first derivative is increasing on the interval, and concave down on I if the first derivative is decreasing on the interval. That's maybe a little confusing, so let's look at the pictures and see what we're actually talking about. So concave up means the first derivative is increasing. So that means it's going to look like this. So this is what we're talking about when something is concave up. Concave down is when the first derivative is decreasing. So another way to think about this is if the first derivative, f prime, is increasing, what has to be true about the second derivative? And if the first derivative is decreasing, what has to be true about the second derivative? Think about these two questions. Pause the video and see if you can say what's going to be true, or just look ahead and cheat if you want. But try to think about it on your own, because it should make sense. Pause the video, unpause when you're ready to talk about it. All right, so if the first derivative is increasing, then the second derivative has to be positive. And again, that should make sense because remember, the second derivative of some function f is actually the first derivative of the first derivative of that function. So the relationships are always still true. So the second derivative represents the slope of the tangent line of the first derivative. And so if the first derivative is increasing, then that means it has a positive slope. So therefore the second derivative has to be positive. Same is true for decreasing. So if f prime is decreasing, then the second derivative has to be negative for the same reason. So this leads us to a test for concavity. So if we let f be a function whose second derivative exists, it's very important, on an open interval I, if f double prime of x is greater than 0 for all x in I, then the graph of f is concave up in I. If f double prime of x is less than 0 for all x in I, then the graph of f is concave down in I. So again, all that's telling us is the second derivative is positive, we know that the function is concave up. If the second derivative is negative, we know that the function is concave down. And what that's giving us is curvature of this shape. So real quick, let's look back here. I just want to point out, so concavity does not relate to increasing and decreasing of the function, because here the function is decreasing and it's concave up, and here the function is increasing and it's concave up. Here the function is increasing and it's concave down. Here the function is decreasing and it's concave down. So keep that in mind. All right, so concavity, it has to do with the curvature of the graph. That's what I just said. Now we're concluding what I just concluded. Great. And we can get that from the second derivative.